Just, I gotta take off in like half an hour.
Okay. Okay, while we're waiting for Greg just grabbing a drink, while we're waiting to start, I'll just say a couple folks have said they've had some hiccups with the human subjects thing. Don't know why. It's just something about their website. So if it does not work when you're trying to the first time and you're like, oh, I did it, it doesn't work, just I don't know, wait 5 minutes and refresh or reload. Don't know why, but it seems to take like sometimes 2 or 3 times. For some people it works no problem, other times it kind of goes a couple times.
When I did it last semester, and I had a problem, and I said that I needed a token for that. So I actually had to go to IDC for them to fix that.
Okay, so far I think, good, thank you for talking about that. But so far I think everybody's been able to do it, it's just you kind of have to, like reload it, and then reload it, and then I'm not entirely sure why it's doing that, but yeah. Cool. Right, I know. Whenever, yeah, it's like whenever mom comes in to look and it works, but like when you're inside. So cool. All right. Yeah.
So I know that we said that you were changing the due date from 11:55 to 11:50 p.m. to 5 p.m. But human subjects training is still at 5 p.m.
Then I'll update. So Greg, come sit here. Oh yeah. Yes. Thank you for telling me. I launched everything way back when. So if I do have a missed one, please call me on it and I'll update it. So yeah. So looking for our surveys and our human subjects, all that kind of stuff. I'll be censusing after 11:50 tomorrow. So okay. All right. So next, what I thought we'd do is just have a little bit more of a conversation. So I'll start off. But then after, a minute or two or a couple questions, then love for you guys to start jumping in. So also, I just want to be super clear by way of transparency, since I didn't say this to everybody. So I am not paid by the metals company, but I do sit on a science advisory board of other, I don't know why I'm on there.
Luminaries.
But other
luminary,
much smarter people than me are on there. And so we, for the last several years, have given advice to the metals company about ways we can minimize impacts, things that we want to change about procedures, that kind of stuff. So none of us are paid, none of us are, but we're like a expert opinion thing. And I also want to say that, we can talk a little bit more. I want to ask Greg about this to start off with, but I want to be clear. This is in the open ocean, right? This is beyond, as we talked about, beyond a national jurisdiction, right? So this is international waters, not US waters, it's not Spanish waters, it's not Australian waters, it's the open ocean, right? And so we do not have before now, we've not had a framework for how to do this. How it used to work in the past is you just go out and you rape and pillage and you do whatever the hell you want, right? And the strongest person or the strongest army or whatever takes what they want and say it's ours, right? This is an attempt to do something differently. This is an attempt to look at this as a shared human resource, a shared thing of all of our planet. And how can we do this in a way that doesn't just let the big, rich, powerful, biggest dog on the block go grab it and say, mine. And as part of that, so it's a challenge. So the metals company is by far the most advanced of any of these efforts around the globe. So they're orders of magnitude farther ahead than anybody else. But there's not a plan to follow. And so with that Convention on the Law of the Sea, one of the elements of that was, hey, let's talk about the framework for looking at impacts. So the metals company is trying to both do environmental impact assessment, what's too much, how bad might this be, what could this impact be, but they're having to invent it themselves. And I'll just say also before I start asking questions, and this is not being biased, but I think it's if I just personally will say if I was worried that this was some kind of PR stunt or whatever, I would not be involved with even just giving free science advice. I'd be like, I don't want to be associated with these people. To their credit, when critics have come up and said, oh, Greg, you guys want to put a thing at the bottom of the ocean and do this? I think it might fill in the blank. I think it might send up a bunch of sediment. I think it might make a sound that's gonna hurt the dolphins. I think it might, whatever. To their credit, they basically said, oh, really? Well, that sounds like a problem. Here's some money, can you please go show me that that's a problem? And what has basically happened is when independent scientists have gone out and looked at that, the impacts that we've seen are almost always orders of magnitude worse. And because we're talking about, it's like going to the moon. And I say, hey, I said, what's this thing gonna do on the moon? Like, I don't know. And you're like, well, maybe it could be this, and if this, and then, and we kind of do the worst case scenario, which totally makes sense. You're like, it could have this bad impact. But when we go and look at it, instead of having the worst possible back of the envelope, it could, maybe, what if, but maybe it could, it's like, whoop. And so, so that's sort of the context. So do you want to talk a little bit about the approach to trying to assess potential impact when you're the first people out there trying to
Yeah, sure.
measure?
Well, one of the things that I did for the company was I needed to frame the experiment. The experiment is, we're gonna go out there and put a 4-kilometer cable down and have a collector system that's like 20 tons. It's gonna kind of hover over the bottom, and it's gonna vacuum up through suctions, sucking these rocks, bring them to the surface, and then we're gonna return the water back to the deep sea that we use for suctioning them up. So the experiment is, what is that going to do to the natural state of that environment? So the way we approached it is we looked at the area like a big cube of water. Think about a big cube of water. And we surveyed and characterized it from the birds flying above down to the dolphins and whales at the surface, down through the mid-water area where you've got enormous concentrations of invertebrates, and right down into the sediment. And so we just picked the ecosystem apart like a layer cake and characterized it. How does it operate normally? And then we inserted our collector into the experiment and measured the changes for us being there. It's as simple as that. And evaluated is there an unneeded or bad release of carbon back into the atmosphere? Is there an unneeded loss of biodiversity? Are we resuspending heavy metals in the water column that will get into pelagic fish and hurt people? Anything you can imagine, we sort of have to look at. And it's really a total ecosystem approach to this. And, it's the first time in the history of the world that a business sector has done this before it's begun its extractive activity. Always before, we've just gone in and started extracting, whether it's oil, or minerals, or gas, coal, you name it. And then afterwards you go, oh geez, I wonder what we're doing. And we sort of look in the rearview mirrors and try to recreate what you did and what impact it had. So I feel like we're taking a very responsible approach. And we have the case now backed up by 5 terabytes of data that we sort of have a reasonably good understanding to handle on this thing.
So for context, when the Deepwater Horizon happened, and we had this massive oil spill, which we haven't talked about yet, that's coming up in a future lecture, but we talked about what happened there, a deep water, not this deep, but deep in the Gulf of Mexico when that happened, and we went to look at impacts, almost nothing known. I'll just say it again. Inside US territorial waters, a mature industry, highly regulated, how many snails are on the bottom? How many jellyfish were near the oil wellhead? And then we had the oil spill. So we could say, oh my gosh, were there, how many jellyfish did we kill? How many sea anemones did we kill? There was no data, or virtually no data. And so when we started to talk about holding the responsible parties responsible, one of the responses by some of the responsible party was, can't prove that. Can't prove that. You don't have jellyfish data. You say you think we killed, I don't know, 1,000 jellyfish? No, that's your opinion. You don't have any facts to back that up. And so this is a very different approach. This is the industry ahead of time. Monitor, show me, let's get all of this stuff. I mean, of course you can't measure everything on the planet, but measure a lot of stuff. And so that's the setting. So going into this, initially, what happened with all the environmental, so initially there's an office in Jamaica that's for the signatories of the Convention on the Law of the Sea, and they are creating the standard. So can you talk about how that is supposed to, International Seabed Authority is supposed to work?
Yeah, well, I mentioned back in the 80s and 90s, there was this global reaction to human presence on the planet and our impact on the planet, both on land and in the sea. It's both, we're focusing on the sea here. And the age of multilateralism was sort of there. And that's a post-World War II phenomenon, where after World War II, we set up a new world order, where we didn't have just the UK kind of calling the shots all around the world, but we tried to set up an equitable system with the United Nations and all participation. And we ended up with treaties, which everybody signed up to. And the Law of the Sea Treaty had it's very technical and dry, but the Law of the Sea had a provision where it would create up a seabed authority that was to manage the seafloor resources. That's actually the reason the United States didn't sign it. They didn't want to be held to account by some unknown in the future council on seabed resources. They wanted to have a freer hand. And you know, that's pretty much the behavior of a lot of countries that they don't have to follow the rules. Why should they bow to the rules?
So we also haven't signed the Convention on Biodiversity. We haven't signed a bunch of conventions that we helped craft.
Yeah, you find in the world that developing countries always love treaties because it's the only power they have in the international space. Is if they want a treaty, they've got whatever the powers that treaty have bestowed upon them, they have that power. And the United States is loath to ratify almost any treaty because we don't want to be held responsible for a treaty. And we don't have to be. We've got the biggest military in the world, the biggest economy in the world, and we can basically do what we want. I'm not saying that's good, I'm just telling you the facts. So, as it turns out, they were probably right when it came to the International Seabed Authority, because what happened there over the last 10 years is, because Bell's company was a full participant in this treaty, in these meetings, but it got overrun and overtaken by reactionary NGOs. They're trying to stop this activity for no good reason, other than they didn't like it.
So first, though, everybody agrees. First, we say, hey, we should monitor. Shouldn't we monitor this before we go out and have the impact? So at first, everybody's in agreement.
Yeah, we were in agreement. We were paying big dues. We were spending hundreds of millions of dollars on research. And then the tide turned, and Greenpeace, World Wildlife Fund, a few others, just categorically refused to entertain the possibility of this happening. Greenpeace actually went out and stopped our research vessel from conducting research.
What do you mean? You mean they actually stopped the scientific monitoring in the high seas?
Yeah, they climbed aboard and camped out on the A-frame in the back of the ship so we couldn't operate. And we were doing the studies that they had been demanding we do prior, but they began to sense that we were doing pretty well. And we were beginning to understand this nut. And they couldn't handle that. And why couldn't they handle it? A couple of reasons. One is they've got a very immature view of the world. Believe me, I had a lot of sympathies with Greenpeace. I actually, in my earlier days, I dated one of the founders of Greenpeace, the gal that named the Rainbow Warrior, the original Rainbow Warrior. So I knew them well. But they had built a brand of sort of fire-breathing, save the world kind of stuff. And they needed issues that people paid attention to so they could raise money. And if you go into a donor and say, hey, would you help me understand the intricacies of all the stakeholders along the coast of California and what each one wants and needs and how to mitigate that and make it all work together, they're gonna go to sleep. But if you say, hey, you want me to stop deep sea mining? They're gonna react, yeah, that's a good thing to stop that, without even knowing it's not really mining. And it's actually the best thing we could be doing now, given the circumstances. So, they log jammed the ISA. It was like filibustering Congress. They just stopped anything from happening. Then they started talking about, oh, well, maybe we'll be okay with it if you do 10 years of test mining. No company could afford to do 10 years of test mining. And the whole ISA was set up to facilitate the exploitation of this resource for the benefit of humanity and to share resources with the developing world. It was a beautiful concept, but it was just stopped dead in its tracks. And now I see what the United States was worried about. That's what they were worried about, why they didn't want to be part of it. Because they didn't want to be held to account by that unruly room.
So in the context of today, how do we say this? In the context of today, there's a lot of anger with each other. There's a lot of people thinking the ends justify the means, right? What we're talking about in this class is we're talking about supportable arguments, rigorous data. What's the best choice? We don't live in a perfect place. We don't live in an ideal world. How do we get to a better place from here? So we're used to saying, rightfully so, that oil companies have, to a large extent, mocked climate change, said it wasn't real. Tobacco companies have, to a great extent, lied about the toxicity of smoking products, right? Unfortunately, this is a case of a group that many of us don't typically lump in with oil companies and that practice. 100% exactly the same behavior, I would argue. So those samples that Greg was, or that monitoring Greg was talking about, there was a test, a little drop down a scale version of the collector, ran it along for a little bit, and we took samples, pictures, everything, came back 9 months later to see what the impact was. This was literally a test of what could this stuff do? That's what they shut down. They shut down the assessment of what the impact was.
Crazy, isn't it?
It sounds made up, it sounds like conspiratorial or
That's what they
something.
wanted.
What's that?
Because I'm not trying to make sense, but I'm saying it doesn't make sense because that's what they wanted.
The answer for a lot of folks that don't have a good scientific basis is to deny the science. Don't do the studies in the first place. Don't collect it. If you don't collect the data, if we defund the agency, you don't collect the data, you can't prove that it was wrong, right? And so we have examples of glass sponges, little teeny delicate dudes that are right here, that if the concerns about kicking up a bunch of sediment, that all these fragile critters are gonna be smothered and killed, right? And we drove a thing through the sediment and it made sediment come up, sure as hell that's gonna be dead, right? And we go back and look and they're still alive a couple centimeters from where the tracker went. Unfortunately, instead of having several hundreds of before after, we have like 12 or something because they shut down the monitoring. They wouldn't let the after the effect get collected.
They get very self-congratulatory and sort of high pompous and feel like they're saving the world. And they're all from the developed countries, privileged families.
Wealthy folks.
They've got nice computers and phones, and they've got nice houses, and they've got all the things they want in life. And they just look at this going, why do I need that? My life's okay. But they're not looking at the rest of the world. I mean, you guys ever heard of the Industrial Revolution? You know, most people wonder what that is. They usually think it's something that happened a couple of years ago. But what that was is a time where we industrialized and we gave the developed world reliable electricity and reliable fresh water. At the basis of it, that's what it produced. But there's 2 billion people on the planet for which the Industrial Revolution never happened. And if some of these NGO righteous people were from one of those countries, they wouldn't be worried about a sponge on the bottom of the ocean. They'd be worried about developing their community, getting better health care for their relatives, and that's really what it's about. And there's just some spoiled, in my view, some spoiled kids in this echelon of NGOs that is sort of ruining it for everybody else. I've become very pragmatic in my views. From the NGO community, I've got every marine conservation award there is out there, given to me for my work over the years. But I won't stand in the face of this kind of craziness.
So I'll say, yeah, question in a second, but I'll just finish up by saying, so we're hearing a lot right now in the news, and rightfully so, about people being canceled, about people saying some view and then others saying, you're not allowed to have that view, therefore you should go away, or you should not be allowed to participate in our arena, our activity, right? It can cut both ways, right? It truly is, we seem to be coming apart on all sides of our society. And this and it sounds like we're maybe too strongly advocating for deep sea mining here, but it is, you all have to make the decisions, right? It's important that we don't start from an idealized, perfect place, right? If there was 1 million people on the earth, we should never mine the bottom of the ocean, yeah? That's not where we're starting. We're starting with wildfires just burned up Malibu and Altadena. This is the world we're in. Business as usual is polluting a crap load of rivers in Africa, child labor, massive human rights violations. That's how we get most of our metals now. And that's, I'm sure nobody wanted to do that, but that's the world we have. And so the question isn't, is this gonna be bad? It's, how bad is this? And how bad is it relative to our other things? And when we talk about other challenges here, that's when we have to talk about the trade-offs, right? What's the more effective one? What's the least bad going forward? And it's been crazy that I'll say, when I've talked to people around this at other universities and other talks, people will come up to me and say, I'm afraid to talk about this in my biology department, in my chemistry department, in the American universities. Because they say, because everybody knows, quote unquote, that deep sea mining is obviously bad, and it's obviously gonna destroy da-da-da-da-da-da. And these are scientists, right? These are folks that should have the ability to reason and pull in information, and it's been pretty amazing, the context. So you guys have questions. William has a question. You guys might, let's start opening up for you guys having questions about this crazy thing that's going on.
I did have a question that what I was looking to ask was clarifying. You so you were talking about the NGO something group. What was the group you were referring to?
The what?
The NGO something.
NGO.
Oh, NGO, yeah.
NGO.
Yeah, that means
Non-governmental organization.
yeah.
Oh, okay.
So that would be like what you might call environmental groups, right? So that's gonna be someone that's not a business and it's not a government. It's something in between. You might also hear them called nonprofits. So the term community-based organizations, there's a lot of different words we sort of use, but basically it would be something like, here it'd be like the Nature Conservancy. Here it'd be something like Ventura Land Trust, that group of organizations.
And Dr. Sumner was saying they're the ones that are not wanting the assessments to be done.
Yeah.
in the first place.
Not all of them, but some big ones are, yeah. They've lost their way, yep.
When the company stopped you guys from doing the assessment, you guys still got before and afters, but it wasn't as much as you wanted, right? And then, did you guys continue to mine after that? Or what was?
There's been this one test, there's been one
Yeah,
test.
no, we completed our study,
Okay.
and we haven't started commercial extraction yet, okay? That's coming, yeah.
So you mentioned that the metals were mostly like copper, cobalt, nickel, but you mentioned they were rare earth metals. Is there like a significant amount of like lithium, stuff like hot batteries?
Well, there's basically everything on the periodic table is in these rocks. And we're evaluating the rare earths now. That was never our intention at the beginning. We were going after the base metals first, but now we're starting to look at the rare earths because they're becoming so important. Well, the way these rocks form is they form like a pearl in an oyster. Basically, there's atoms of these metals are in solution in seawater. And water's the ultimate dilute solution substance. So it has atoms of nickel, cobalt, manganese.
I'm gonna go grab some to
everything
show
else,
you while he's talking.
including gold, everything's in water. And they form, there's usually a little piece of sand or shark tooth or something at the center of each nodule. And these metals accrete to that just very slowly over time. And they take on the characteristics of the water around them. So the water around them in the Central Pacific, in an area called the Clarion Clipperton Fracture Zone, it's about 1,000 miles from here, is particularly rich in these metals. And that's where we go, where the right combination of metals that we want are aggregated. If you go to other places like the west coast of Australia, it's mostly iron, but we don't need iron nodules. There's plenty of iron on land, it's easy to get at. Yeah, back there?
I was just gonna ask a clarifying question on the timeline. So you started doing the survey, you were stopped, and then did you guys resume the same survey?
Yeah, we kind of talked about that interruption as an example. It wasn't a showstopper, but it did happen. It was just really to point out the craziness of it. And we completed the work, yeah.
And then you guys have been like talking about the results and the data, but the only like organism that you guys have mentioned so far is a sponge. I'm just curious, like what were the results of this thing?
Yeah, the results, it's far too much to really continue here, but I could say that scientist Brian O'Malley, you saw the video on, who was looking at the foraminifera. Turns out foraminifera is about 80% of the biodiversity of the sediment of the seafloor. And there's a whole bunch of different species of foraminifera. And we did find that after disturbing it, we come back a year later, they've rebalanced and have the same composition as before. That's one thing. Now there's deep sea corals on the things, there's some sea cucumbers that wander around the bottom, there's bacteria. We look at all that stuff.
I'm gonna pass these around. So one is just a nodule, just be careful, it's kind of brittle. And then this one, you just hold this gum. So this is inside a lot of these, not every single one, but inside a lot of these we find shark teeth, and we're trying to figure out how they grow. So they actually grow on the back of the shark teeth. So you can see these guys around these guys. So I'll just pass it around. These are forming, and this is one that's sort of already formed.
That's really cool, Sean. I don't think anybody's ever done what you've done there.
Well, you know, I'm so brilliant, clearly.
Yeah.
I was gonna ask, just because kind of what you were saying, what is like the official recovery rate? You said you went back in a year. Is that for that particular species, like the recovery starts happening, or is it like somewhat immediate?
Well, we looked at because most of the biodiversity was foraminifera, we wanted to look at that in particular. That seemed to recover quite fast. You know, hard coral creation is not going to recover that fast, but it's not a really big part of the biodiversity either down there. So it's a complex story of different things, but it's not easy to answer your question. But the bottom line is, when you look at the assessment, you say, okay, is the amount of disruption and harm worth the benefit to the world? And we've determined that it is by far, especially given all the alternatives.
And then I just kind of have a question about like how they're formed. How do the metals get into the aggregate? Is that runoff? How is it getting?
Yeah, it's runoff from the Rocky Mountains, from the Andes, and also from hydrothermal vents that are around Costa Rica and the ridge. There's a lot of hot water pouring up from the bottom of the sea, and we believe that's what's loading the water over these metals.
More than runoff probably is those vents.
I'm not sure which one it is, but there's a lot of these metals in the mountain ranges of North and South America, and there's a lot of runoff from those. Could be that.
I'll just add one thing that I'm particularly interested in as a restoration person, is if the answer was really, and here's an example of why you want, one of the many reasons why you want good data. If we literally were just gonna kill everything, like who cares, right? If like going down there just nuked everything for a while, should do like a clear cut, like strip the forest, right? Suck this guy up and then go right here and then go right here and just take it all, right? Because it's all gonna be damaged or harmed. But if instead, as it's appearing, stuff can recolonize, at least some stuff can recolonize fairly fast, that suggests maybe a path and then maybe leave a meter or two in between. And then a path, and then a path, you know, and so in other words, you can, instead of nuking everything, you can checkerboard it, which should theoretically allow faster recolonization, faster restoration. If you didn't have that data, you wouldn't know that, and you would just, you know, bulldoze the entirety of the area.
What about like the replenishment of the resource itself after mowing it? How long till that resource is back in that?
About 8 million years.
Okay, so once it's gone, it's gone.
Yeah.
Okay.
I thought did you not have your hand up?
I did, but it was about
Okay.
that same,
Okay,
like how
cool.
renewable is it, which is not really.
Effectively non-renewable.
Yeah.
Go ahead.
I know that, or I've seen that, I mean, initially the idea was that it would send like a giant plume up of sediment, and I know that now they're thinking that it's like less of, you know, a couple meters somewhere.
That's right.
Like, does that not still kind of cause disturbance to like
Sure.
environments that we don't really know a whole lot about? Like, we're just now learning about the deep sea in detail.
Yeah, we're finding the plume, the term is called flocculation, that's when the sediment gathers around it itself and sinks back. We're finding that it flocculates quite rapidly and drops right to the bottom, and that, you know, the animals that are down there are able to push it off, it's not really killing them. And is there a change? Yes, there's change when you walk out the door of this building, you're changing the world in some way, but it's minor. It's not doing whole-scale destruction of the habitat. Yeah,
But I'll just add, that's a question you guys are gonna have to answer in a coming assignment, which is, you know, we have some perspective here, but you are welcome to have your own, but you need to evaluate that. You need to evaluate, there's no such thing as no impact. The question is, what is this impact compared to the strip mining of the Indonesian rainforest, compared to the Congo decimation, that kind of stuff?
I was wondering, the calculations that you're doing of the impact of land and mining, that includes the processing of the metal, right?
Yeah.
So then, are you guys including in your calculations their impact,
Oh, yeah.
how and where you're gonna be processing your metals? And so where is that gonna be? Is that gonna be on US land?
well, right now, we can process them in existing facilities in Japan and Indonesia. And then we're looking at building some facilities in the United States. But you could have a nursery school right next to the facility. There's no toxins or anything bad about it.
Yeah, just for perspective, when you guys think of mining, you think of digging up a bunch of rock. And there's a small percentage of the stuff you want in there. And so you need to like physically crush it up a lot of times, and you need to add a lot of, say, mercury or acid, and then you create a sort of secondary thing, and then you take it over here, then you kind of do something over here, and all that's a lot of energy, and a lot of crud going in, and a lot of crud coming out. This is basically put it in a big furnace and making it very hot.
Yeah.
It turns into sand in the metal. So there's no leachate, there's no acid tailings or anything like that.
And that's the same for every single nodule in the whole ocean, no matter where you collected it from.
Yeah.
Even though it's the same chemicals.
If you look at that stuff that's circulating around, it looks, I mean, it is delicate, but it's like, looks very sandy, right? It's a lot of sediment in there.
So I guess I'm just confused on the like chemistry of it, that you have to put acid in order to separate
You
metals
don't.
and stuff on
No,
land.
no, it's-
Oh, on land you do, yeah.
But the same, like, couple of elements, because they form underwater, you don't need an acid to separate
Yeah, that's right.
them from each other.
Yeah, it's a completely different formation process. You've got to precipitate nickel out of what's called nickel laterites these days, which it's basically dirt under the tropical rainforest. And it's like magic. these chemicals on the nickel falls out. But they're really bad chemicals, and they turn the water red.
On the land, the land stuff.
So many questions, yeah, go ahead.
So on our survey, I'm pretty curious about this, but we asked people if we were to encourage more deep sea mining, where would be places they would think.
Or more mining,
would-
where were they?
Yeah, so one of the options was, of course, the deep sea and the Salton Sea, and I was wondering, I don't know too much about the Salton Sea or where it is, but I was just wondering what's like, I guess, differences between the two, or if one is better than the other technically. Do you two know anything about that too much?
I've got a map, it's a global map on nodules, what we know about them, and I don't have to recall it offhand.
So she talking about the Salton Sea, so that's
Yeah.
lithium. So that's
Oh.
that's not all the metals we're talking about, that's a subset of, there's a few other things, but it's mostly lithium that they're going after there.
Oh.
And that's essentially, there's different processes, but it's essentially taking briny water and there's different companies with different extraction techniques, but essentially producing lithium from essentially groundwater there.
Okay, so it's technically two different processes of like
Yes. Yes.
mining for rare earths.
Yeah, so the stuff on land is different. So again, we've had a couple questions on that, right? So the stuff on land is either getting ore, rocks that is, the metal is bound to some other compounds, or sometimes taking out water that's been mixing with different high temperature materials and stuff. And so both of those though are different and require lots of chemistry as compared to the deep sea mining stuff, which is essentially get it really hot and it falls apart basically. Not quite that simple, but basically that's it.
How about here?
So how long do we have of like mining the resources, like what percentage of like, I guess, roundabout, like, how much would we?
Yeah, I know what you're getting at.
Yeah, I think.
Now, our calculations are that, there's another whole discussion here about turning it into a closed loop, so that we're no longer throwing the metal away in the landfills, but we're reusing it. Because metal is 100% recyclable. And we believe, we've done the calculations, we believe that if we extract a whole bunch of nodules between now and about 2050, we'll have enough metal recovered from the earth to not have to mine anymore. If we're really good at recycling, we can just keep reusing it over and over again.
Is your company the only one that's looking into it?
No, there's a couple other companies,
Okay.
but we're far ahead of them, we've been at it longer.
Do you feel like as it becomes more popular, if it becomes more popular, that the ISA would have like a harder time, like, ensuring
It should have an
everything is
easier
done
time.
correctly?
It should have an easier time. The ISA is at risk of making itself irrelevant though. Because they haven't been able to perform their role. They were not created to stop the industry. They were created to allow it to go forward with regulation and good environmental practice. But they got stonewalled into this NGO cloud, got in too early. And they were too nice, it was too democratic. They basically got kind of filibustered and work wasn't allowed to proceed as it should have.
Is your data publicly available?
It is all publicly available. Absolutely, that's number one priority, number one requirement.
Okay, so else you were saying something about, you were saying, how much is available, what else was I gonna say?
Could it completely replace the fossil fuel?
Oh, I know, could it completely replace, well, we're trying to electrify our
Right,
energy.
so if that 2050 mark is interesting, I'm just wondering could you elaborate more on that?
Yeah, we feel that if there's gonna be hundreds to thousands of times more metal required, and that includes that 2050 calculation, to where we should be transitioned to renewable energy by then. That is wind, solar, nuclear, and kinetic, there's all kinds of renewable energy. And if we do that, you know, it's always hard to say what the world's gonna accomplish against what it aims to accomplish. Then things should get locked into place and there'd be enough material to keep just reusing it over and over.
And then this industry would shut down at that point?
We envision the industry transition into recycling industry.
Oh, okay, so you start using the same locations that it's processing for recycling?
Yeah, we've even thought about not selling the metal, but leasing the metal.
Yeah, I saw that, like renting the metal.
Yeah, it's one of the ideas, yeah.
I know, as I say, when Nicole asked the question, so another one that's commonly said is we shouldn't do any more mining, we should just recycle what we have, which recycling is great, but to speak to what Greg's talking about, the orders of magnitude more material we need to transition away from a fossil fuel economy, we just don't, there's orders of magnitude not enough. So that argument, it's not a bad idea, but it can't possibly get us to the math that we need. The other one that you'll hear sometimes, why don't we just go mine an asteroid, right? That would be great. Ain't nobody mine an asteroid in the next couple decades, right? That fire just killed 100 people, right? This thing is happening right now. We don't really, this is an opinion, this is a personal opinion, but I don't think we have another few decades to just doink around and study something. Stuff is unraveling in front of our eyes, right? We see it every day. Environmental justice stuff, we see it every day in terms of energy systems, we see it every day in natural disasters. It's totally fair to say, hey, this isn't the option, but then you have to talk about how long would your other solution take to get, you know, just saying go off the planet ain't gonna work in my lifetime at least, and probably not your lifetime either.
Are currently chemists working to make like some new process to speed it up and make that evolution, like synthetically?
To pull out the metals out of the water?
Make it faster than years to make the rock.
She was asking if there's any chemistry to try to encourage the faster precipitation of metal out of the water in the first place.
Not currently, but maybe in the future, yeah.
Good idea. Good idea.
What's the progress of your EIS? Because I know you were mentioning that you're doing the planning for that study.
Well, we're in the process of finishing the analysis. We'll have it done within 6 months.
Okay.
We're working on about a dozen peer-reviewed papers right now.
So once you do that, are you looking more at studying like different, more like macro life out in the sea, like more like sea stars, sea cucumbers? Because I know you said
Those are being done.
your
Those
data-
are.
okay, those are happening right now.
Yeah, and we're also looking at long-term monitoring plans too. So we're gonna own this part of the seabed forever. We're gonna have to keep monitoring it over time and see what happens there.
So yeah, that's a fundamental part, which is ongoing monitoring. So not just we did the studies beforehand, but constantly camera, I mean, not this idea, but maybe cameras, maybe other things that we're looking the whole time at what is the impact, what's going on. So that's a commitment. And I'll just say, to be totally clear, I don't know if Greg will say it's not, I don't want to be disparaging to anybody. I'm not trying to be disparaging towards anybody. I'll just say some of the other countries that are involved with extractive industries don't care about environmental impact review, don't care about human rights. And if we can imagine, if something happens, if suddenly tomorrow the metals company goes bankrupt and they suddenly stop doing this, the next players coming down the pike are very unlikely to do any environmental, or to do anything like the environmental monitoring we're doing. So another whole part of what Greg has been working on is to try to set a very high bar.
Yeah.
So whoever comes back, here's the expectation. Maybe we find something's bad, or maybe people don't believe this, or whatever. But the next folks that come through should go through a similarly high standard to assess impact, assess what's going on. And I'll just say that not everybody is committed to that type of expense, and not everybody is committed to that type of philosophy of trying to minimize harm. I think that's fair to say. Is that fair to say?
Yeah, absolutely. Go ahead.
I know you haven't started commercial extraction yet, but how would you think on energy return on investment
Oh, yeah, no, the business model for this is outstanding compared to land mining. You know, what's it called? I learned all these financial terms once I got involved in this
What,
business.
return on investment?
Yeah, the return on investment, there's also a curve, cost
Oh, yeah.
benefit, and we're way over inside, we're way over to the left, so it's a very efficient model financially, as well as energetically, as well as any way you wanna look at it.
So this is just to clarify, is like one of the main goals of your mining to help industrialize developing countries?
One of our goals is to share the benefits of this industry with developing countries, yes.
Okay. And then, is there a way for you to monitor how you would be able to recycle the metals that are helping the developing countries?
Well, the recycling won't necessarily help them, but the cash from the industry can help them, and participation in the industry can help them. We're already spending money on training programs, education. We have developing country partners.
Yeah, I think what I'm asking is there a way for you to monitor how you can recycle the metal they're using? They end up using.
I'm sure that'll happen in the future, yeah, we're not there yet.
So other kinds of clarifying things, since we haven't talked about this yet with oil and gas, it's the same thing with wind. When there's a resource, let's take the example of in the US. There's something, let's say gold, or let's say oil, just some resource, right? So for us, generally speaking, that's say on public land, okay? So it's on a national park, it's on Bureau of Land Management land, it's on something. And so when the government or the owner wants to use that resource, they carve it up into what are called leases or plots or areas. And then they might do a study, the government might do a study, or they might allow Autumn to come out for a week or two or something and take some samples or something, right? And then either I give this data out to you, or different people have their guesses, and they guess as to how much gold or how much oil is here, right? And so he has his guess, I have my guess, John has his guess, all that kind of stuff. And then what happens is we have an auction. And we go, here you go, here's plot number 1, here's plot number 2, and there's different ways to do it. It's usually a blind thing, right? So he makes a bid, he gets all his investors, and I think we can spend $1 million for this, because we'll end up making $10 million, or whatever it is, right? So he puts his bid in, I put my bid in, and then when the bidding's done, you open it up, and whoever is offering me the most money, says the government, I give you the lease. Yeah? So the framework for the open ocean, right, that doesn't exist. So back in the day, it was just jump down and grab whatever the hell you want. What the framework from the conventional law of the sea has done is carved up areas like the Clarion-Clipperton Zone. There's this area between Hawaii and Baja that we're talking about, this relatively high concentration of nodules, and all the countries of the world have chunks of land in there, right? And if that chunk of land has relatively few nodules, they have a bigger chunk of land. If it's a relatively rich and estimated rich, they have smaller. But all these countries can decide what they want to do with it. The United States can decide what it wants to do with its, Finland can decide what they want to do with its, etc. And so what he's talking about to get at this question is, they've essentially said, hey, this is this small island nation or this developing nation's plot. Hey, you guys, is it okay if we mine your lease? And they go, yeah, sure, this is how much money we want. So the metals company pays them money, and they get their money, right? And then the metals company is trying to extract it. Does that make sense? So it's not as if like they're given a percentage of every dollar to, right? All the other ways it works, you pay at the start, and then if you make money, great. If you make zero money, if there's no nodules there, tough luck. You still pay for the oil or for the gas or the gold or whatever it is.
What is the actual process of the deep sea mining? How do you guys collect it, and how do you guys bring it back up?
The way we collect it is this collector vehicle kind of floats along the bottom, and it squirts water jet down to the nodule, pops it up into the water column about 5 centimeters, then it gets sucked into these suction things. They come into the collector, shakes it, get the sediment off, and it sends it up a riser. It's dumped on the
A
bottom.
big tube, a big tube.
Then the water that it was used to take to the surface is brought back down to the bottom and returned.
4 kilometers.
Yeah.
And there's a collector ship like this, like right above, the robot's crawling along and it's going right above. So this is also like going to Mars kind of technology, because without modern technology, like the ship would go a little teeny bit and it would rip it off the ground, or the thing would snap or whatever. And then there's another ship that's gonna come up, and once the hull gets full, you move that to that essentially shuttle, and that shuttle takes the stuff back. So the main ship is still the whole time going.
You've got good video of that happening. So,
Yeah, I'll show you guys a video in a second.
I know you mentioned one of the things that got you into marine conservation was like seeing plastic at the bottom of the ocean. Would you say you get any significant amount of plastic along with the metal, like up the riser?
we are looking at microplastics, of which there is some, but I wouldn't call it significant, no.
It's small.
But we have found microplastics in the sediment down.
So, I know you said like you get the metals from like shooting a jet and then it pops up or something. I know there's animals that live under the sediment. How far down does that like impact go, and do you guys sample those animals too in your assessments?
We sample everything, but the impact only goes down at like a centimeter or so. It's very, very shallow.
And nothing lands on it?
Well, I mean, there are these like tractor treads that kind of tick, 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 tick. So, theoretically, if you were a worm right there, it would kind of tick, 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 kind of squish
There's
you.
a point at which you have to sort of get realistic about this and realize that going along the seafloor with a tread and crushing a few worms here and there is not a big deal. Especially when the alternative is strip mining a tropical rainforest and displacing communities. And then after you've displaced them, you're gonna make them sick with the toxins you're leaving behind.
Other questions? William?
From what you do mine, how, like, let's just say, I don't know what will be a product from these, but metal, let's just say for a car, how much would like one day's worth of mining produce, like, as a new product?
We're probably gonna collect about 300 tons an hour of nodules, which, it's probably, no, probably thousands of cars a day, a lot. Good question, though.
Actually, good stat,
Go ahead.
You mentioned that in the extraction, there's sand that comes out of it. What do you do with the sand, like after?
We leave it there.
Oh.
Oh, the sand
Oh,
out
no,
there.
no, in the
Oh, the
furnace.
processing, we use it for concrete formation. It's a great mixture for concrete companies.
How like well distributed across the planet are like all the, like are there regions where there's more?
Yeah, there's nodules everywhere, but then there's real dense concentrations, where they're really spread out. And the fact is, we really don't know, because we haven't explored the deep sea very well. We know about this big patch in the Central Pacific, which has enough metal for the world for hundreds of years, if we just stay there.
Are you, okay, so isn't the metal somehow magnetic or does like electromagnetic stuff?
No, you don't have to worry about that, no.
No?
It's not that
It's not that kind of
density
It's not that kind of
with the
metal.
sand.
Like if you remove all of the metal, isn't it gonna throw off
No,
stuff?
no. No, the metal, the magnetic fields of the earth are developed by a huge, half the earth is nickel. You go down deep enough,
The core,
it's this molten nickel core, which you can't even imagine how big it is. And that's what creates the Van Allen belts and the electromagnetic field of the earth. What we're dealing with is like nothing. It's like one hair on your body compared to everything else.
So I'd like, Dr. Oh, sorry, go ahead, yeah. Oh, perfect, that's exactly what I was just gonna bring up. Okay, good.
With the deep oxygen? Yeah. It's just not true.
It's not true.
dark oxygen is something that the media got infatuated with, and it's just not true. It's like junk science. That's all I can tell you.
So that is referring to a paper that was published in Nature,
It wasn't Nature,
or Nature Geosciences.
which is a totally different.
Right, Nature Geosciences.
Yeah, it's a real
Nature Geosciences.
trashy little journal.
So, let's see, how do we talk about this? So when we talk about our research, right, we're taking lots of samples. You guys are going out and sampling a lot of different people, right? You're not sampling all your friends. You're sampling these folks over there, somebody in Ojai, somebody in Santa Barbara, right? We want a representative sample, right? We also are trying to look at our error. So when we say, whatever, how many grams of seafood are people eating on average every week, right? We have an average and some noise around that, right? So everything we do, there's error. So we never have a perfect sample of everything, right? So what unfortunately unfolded is what we're talking about, since we haven't, maybe not everybody knows about this. This paper was published, what, a year and a half ago?
2 years ago.
2 years ago. And this researcher said, actually what I was passing around, if you drop that in water, it's gonna bubble out oxygen. It's gonna make oxygen. And if these guys go and suck all the rocks out of the bottom of the ocean, we're not gonna have oxygen in the ocean. That sounds bad, right? Right? I mean, it sounds bad to me. It's like, oh, that sounds horrible. Except it was all made up. Only two reviewers reviewed this. The reviewers, not particularly the most robust folks. This was a professor who has since been fired from his university for reasons that they won't discuss because personnel matter. But
It had to do with the dark oxygen.
I would just suggest though that if some person was discovered making oxygen from water, that's a probably pretty smart dude. We should probably hire that dude and give that guy more lab space and get more, right? Kind of weird that you'd fire that person and not talk about why you fired that person. That person had a graduate student. Actually, it was the graduate student's work. That person published the work before, didn't mention anything about oxygen being produced. And we could spend a long time going through all. There's been 7
There's been 5 or 6, 7 rebuttals published about it.
other scientific groups from around the world who are experts in marine chemistry and this and that going, this is BS.
It's bullshit.
This is total BS. Now, sometimes bad stuff gets into journals, right? So what's our convention of statistically significant? P equals 0.05. 0.05. 0.05 is 1 time out of 20. Our standard, even if you and I are being super honest and super good scientists, on average, if all of our papers are published and we find P equals 0.05, it's statistically significant, one out of 20 of us are going to be wrong, right? So just the way the data fell out, it happened to look that way. So there's always error. So we always talk about our level of confidence in something, what are alternative explanations, etc. Not this guy. Not this guy. And so, but we do make errors. We make errors. What's supposed to happen is the journal, so if I publish a paper, I'll talk about an oil spill paper. So I published an oil spill paper about what happened with the Deepwater Horizon. Instantly, the American Petroleum Institute, which is the oil and gas's lobby arm, were on to the journal like 2-3 days after it was published, and they demanded to have a letter. They knew that what we wrote was correct, but they wanted to challenge it. So they put a letter in. And they have a lot of money, they have a lot of contacts, so they got a letter. So then we wrote a rebuttal letter to that. So that wasn't a retraction, that was only a letter, right? That showed up on the website like 2 weeks later. This has had many people write in, but Nature Geosciences has not retracted it.
And they won't even publish our rebuttal, and they won't say they won't publish the rebuttal. They just keep putting us on hold. Because they're so embarrassed, is what it is. I don't know if they're hoping for it's gonna go away.
And it's one of the most cited papers in the history of this journal.
They made a huge mistake.
So what you'll also see, we see this with Deepwater Horizon, with the seafood, we see this with Fukushima. When the problem happens, often it's a human behavior thing. When the wildfire happened, oh my God, wildfire! And then we're like, oh, maybe the wildfire wasn't so bad, or the poisoning wasn't so bad. That doesn't get anywhere near the media coverage on average as this start of the crisis. So when this dark oxygen paper came out, everybody and their brother started covering it, right? Why not? It's a paper in a scientific journal, sounds legit. But when the correction, when the people started critiquing it, that's gotten almost no interest. And so as a consequence, because we live so much in our social media world now, that stuff is out there, it's stuck, right? It's stuck in the Google search engine. So if you say dark oxygen, if you guys Google that tonight, I'm sure, the first 100 things you find are gonna be, oh my God, it's so bad. So it worked really, really well. It worked really, really well. It magically came out right just before, randomly, the International Seabed Authority was about to take a vote on who would be their leadership.
The guy's a charlatan.
So again, we have to use our science. So this is not an issue of scientists good, other people bad, right? There's good scientists and bad scientists. There's good environmental groups, not as good environmental groups. We have to always use our full rational evaluation. Don't believe when I say something. Don't believe when he says something. You guys need to check it, verify it. And the danger right now is so many people are counting on you not checking anything. They'll say some crap about some political person. They'll say some crap about some environmental pollutant. They'll say some crap, whatever. And they predict that you will not scratch the surface. You will not look any deeper. And this is not a conspiracy theory thing. It's just how our echo chamber is evolving.
It's a little bit off topic, but like, how do you combat that in an ethical way? Because like, it seems like no matter what you do, that people are just gonna think that that's how it is. So how would you like remedy that?
The decision makers know what's right in the permitting. Tom Peacock, the MIT lab, heads of MIT labs, he said this was decided back in 2004. He said there's no dark oxygen. It's the funniest thing that's ever happened, right? The way it's taken off like that.
It's a sensational name.
Pardon?
It's a great name. It's a great marketing name.
Deep ocean.
Oh, yeah,
dark
yeah.
oxygen.
It's super sexy.
Yeah.
I know that, like deep ocean environments are specifically like a big part of the planet's carbon cycle, like naturally. Does pulling the polymetallic nodules off the seafloor have any effect on like the carbon cycle?
Zero.
So I guess my question is, the answers that you're giving us, that's from the perspective and the like experience of your company specifically with very high values. But you, as you've stated, there's other companies, other countries that have these very similar goals. And even though you guys are so far ahead, there's no way to guarantee that someone isn't like right behind you. And is there a way that they will be going about it? I'm not saying that like if you stop, everybody's gonna stop. But can we have a conversation of what it looks like if everybody is doing it in the ways that are not the most?
Well, it needs to be regulated.
Friendly
The
way.
industry needs to be regulated. The regulator needs to stress what you're concerned about. That everybody does it the right way. Right?
Right.
Is that what you're saying? So that's not our responsibility, that's the regulator's responsibility.
So I guess I'm just wondering like, what are the impacts when someone else does it a different way? Cause I just like, this is the first and only
Well,
way that
it would
we
have to be looked at and analyzed,
So I would also say that, and we'll get to this more when we start talking about, in many weeks from now, when we start talking about our sustainable seafood surveys. But you all have power, right? So you could choose to buy a shirt made in Indonesia, or a shirt made in China, or a shirt made whatever. And so, for example, one of the things that started with President Biden and has continued in the most recent federal policies is we want to have metals for, say, electric cars and things that are sourced from American or Western countries that have these standards in place. So that if there was an actor that decided I'm just gonna go, do whatever I want, that, say people selling car batteries to US companies, there'd be some disincentive for them to use those cheaper things. That's one mechanism, there's other possible ways, but that's one way. Somebody else had a question, Micah?
Okay, what if you found a dinosaur bone, would you partner with an paleontologist people, and then you could do what
You mean the bottom of the ocean?
Yeah, and those little things.
We have found megalodon shark teeth, which are contemporary dinosaur era, and we report that, and it's part of the scientific study.
There's a nuts amount of shark, like the bottom of the ocean is covered with shark teeth, it's insane how many.
Wouldn't that help you guys be able to continue to do it?
Sorry, I couldn't hear that?
Wouldn't that help if you keep finding fossils?
We haven't found any dinosaur fossils down there.
Cool, all right, so we can keep talking this, but we have a little bit of time left. I wanted to sort of talk about other aspects of Dr. Stone's career and see if people had other things they were curious about. But I'll just say, can you talk a little, we've not talked about marine protected areas yet, that's again coming up in future weeks. But can you talk a little bit about, from your time with, when you were at the aquarium, what was the idea behind the Phoenix Island protected area?
Yeah, I'd be happy to. And I'm sorry, I gotta say, I didn't know this was gonna go so late.
Oh,
I've got to leave pretty soon.
Oh,
I got a thing,
oh,
I
yeah.
gotta go to.
Okay, sorry.
I thought this went till
It's
5 or
6:25
5:30.
right now.
What?
It's 6:25, right?
Yeah.
Yeah. Okay, sorry, go quick, give us a quick version, sorry.
Well, yeah, back when I was involved with Kiribati and the Central Pacific, we didn't have any tools for marine conservation yet. We knew there were a lot of things wrong with the ocean, we didn't have any tools. And just leaving the area alone, while it sounds so logical today, it wasn't self-evident back then. People had never done that. And in this case, the country benefited enormously from selling fishing rights to other countries to come in and take the fish. And it was a developing country that relied on that revenue for their well-being. So we came up with a model where they would get the compensation for the fishing rights that they were losing in return for shutting the area down and letting the tuna stocks recover. So we had to come up with a financial model, and it was the first big marine protected area on the planet, and became the world's largest World Heritage Site, and it was a long haul pulling that off, and there's been some problems with it in recent times having to do with changes in administration in that country, but that's just the way it goes. Now, marine protected areas is a well-proven tool for allowing the multiple uses of the ocean. It just makes sense. Take a certain percentage of it, leave it alone, and let it spill out its abundance if it's left to its own devices. But you need to monitor that, you need to understand the dynamics of it, how much it is. I'd be happy to come back and talk more about marine protected areas.
Yeah, I'm so sorry, we're keeping them too long. Anybody have any questions about that, or about the work for the UN, or anything of that nature?
I just had kind of a broader question about for this emerging industry as young scientists and stuff, what do you think is the best way that we could sort of find our way into that job world and getting involved in that kind of science? Because it seems like it's super cool, but it also seems definitely I'm sure it's a competitive thing to be able to participate in.
Well, I think the question really is, what's the so-called blue economy? Which is this ocean renaissance I was talking about, and how we're beginning to really re-engage with the ocean, whether it's waterfront marinas, whether it's cruise ships taking people out on tours, whether it's the shipping industry, whether it's the mining industry, whether it's the fisheries industry. I mean, there's so many things going on. How do you engage with it for a job? Look at an industry you're interested in and find people that are working in that industry and go offer yourself up as a free intern for 6 months to that person That's one of the tried and true ways of cracking your way in. I went to graduate school with a guy who did that in the cruise industry. He wanted to be in the cruise industry down in Florida, so he went and volunteered with the CEO, said, I want to shadow you for 6 months. The CEO was delighted with the idea.
Free labor.
Well, it also made him feel important, made his ego go big. And after 6 months, the guy wrote his thesis on the cruise industry, highlighted this guy, and the guy hired him right away. You know, that's one thing you could do. There's no simple answer. It's understanding the industries, finding the players in the industries, and then going after them with some aggression. And I'm not looking for anybody actually, but if you run across somebody like me, you come after me. Hey, how do I get involved? What do I do? I'll volunteer my time if you don't have a job right now, but I want in, and then if I don't work, go to the next guy.
Totally.
The point is though, there's a lot of opportunity, I think, in the ocean. A lot of need, that's for sure. Globally, if you look at the ocean, I think it's a $13 trillion economy overall, but we only invest $1 trillion a year in it, which is totally out of proportion to the opportunity. So it's like the elephant, the blind man touching the elephant. He doesn't know what part of the elephant he's touching because it's blind. It's the same thing with the ocean. You touch one part of its economy, and what's the rest of it? All to Sea. You should check out All to Sea down in Long Beach. They're a really great outfit, and they're looking at all dimensions: aquaculture, renewable energy, protected areas, communications, movies.
In San Pedro Harbor.
Yeah. And there's a lot of state jobs, I think, in California. You can go find an NGO that, Rod Stewart said, find a rock and roll band that needs a helping hand.
So
It's not an easy answer, but the answer is you gotta be aggressive. Know what direction you want to go in and swim that way fast. It's not going to roll out to you.
So Greg's got to take off, and so I want to give you guys, as he's wrapping up, if you guys want to talk to him for a minute or two face to face. But I also want to say that while it's very premature, but we're working on a potential class. So with our funding situation on campus, right, we're not able to do some of the historic experiences, but we're working on trying to do experience. He also has established an NGO to try to support small island nations and all this kind of stuff. And so we're talking about the possibility of doing a course in the summer to the Kiribati, where we would help do baseline monitoring, environmental monitoring for what would be a more sustainable development, both a marine research lab and a sustainable ecotourism thing that would be run by locals, for locals, and all kinds of good stuff. So if you guys are interested, we can talk about that. But the hope is that in August, we would have an opportunity for you all to maybe come spend a couple weeks in the South Pacific helping, not deep sea mining, but definitely helping conservation, direct help with one of our small
It's a life-changing experience, I can tell you that.
That'd be pretty cool. Hopefully it'll be pretty cool.
Yeah, I always enjoy coming here and talking to you guys, so thank you for your attention.
Thank
you.
Awesome. So we gotta get out of here, but we'll just take a quick break if you guys want to walk up and ask him anything for 5 minutes or so while we're packing up, and we'll probably call it there. So I'll just reiterate that if I have the settings for your surveys or whatever at 5 o'clock, I'll change it to 11:50 tomorrow. But if you guys can get those done, look, even if you think you have your stuff entered, go look to see if you have any yellow cells by your things and enter them. If you are having problems with your logging on to do the human sub-base training, the answer is just try it again, refresh it, try it again, go get a soda, come back, try it again. I don't know why it does that, but try it, yell at it.
Turn it off, turn it back on again.
Should work. Okay, cool. If you guys want to talk to Dr. Stone, come on up and say hi.
Throw it off the plant and hope for the best.
Throw it out the window, see what happens next.
Dr. Ann.